Hello everyone, welcome to the Rapid Notes. In this video, we will learn 6 basic terms in theory of computation. First is alphabet. Alphabet is denoted like this. An alphabet is a finite set of symbols used to make strings. For example, A, B. Here, A and B are the only symbols available for this. We can also write like this: X, Y, Z, anything. It is a non-empty set of symbols. This is very important point to remember. Non-empty set of symbols. Next is string. String is a sequence of symbols taken from the alphabet. If sigma equal to A, B, then some valid strings are A, B, AA, AB, BA, etc. It also contains empty string epsilon. Epsilon contains no symbols. Now, length of a string means number of symbols in it. For example, length of this string is 3. Length of epsilon is 0. What is language? Language is a set of strings over an alphabet sigma, which is formed from symbols of sigma. Suppose sigma is A, B, set of A, B, then language can be epsilon, A, AA, triple A. Then what this language can be called as all strings of only A's including epsilon. So we can say that this language contains only strings made up of A's, including the empty string. So remember, we can generate strings from alphabet and we can generate language from strings. So we can write like this: alphabet, strings, and language. Next is expression. Expression is a combination of symbols and operators that describes a pattern. For example, A plus B into A star. Here plus means either A or B. This dot means concatenation. And this star means 0 or more times A. We can read like this: this is an expression using symbols A and B and operators plus, concatenation, and cleanly star. What is regular expression? Regular expression is a pattern used to describe a language. Suppose we have given a language like this that start with A or B followed by 0 or more A's. Then regular expression of this language can be this: A or B, concatenation, A star. Which language this regular expression can generate? Like this: A, B, AA, triple A, 4 times A, B, AA, B triple A, etc. Now let's understand what regular language is. Regular language is a language that can be described by a regular expression or accepted by a finite automata. Now let's understand how to identify whether a language is regular or not. Suppose the language is L1, all strings over A, B that end with A. Can we write regular expression for this language? Yes. Regular expression for this language is all strings over A, B that end with A. That means at the end we need to write A. And A or B any number of times. This is the regular expression for this language. So this language is described by a regular expression. So the given language L1 is the regular language. Now another way to identify the given language is regular or not is we need to ask one question. Do we need to count anything for this language? The answer is no. Why? Because we only need to check the last symbol, that is A. If the last symbol is A, accept the string. If the last symbol is not A, then reject the string. Suppose if the last symbol is B, then finite automata will reject it. Suppose A is accepted by this language, BA is accepted by this language, but AAB, this string will not be accepted by this language. Now let's take one another example, language L2. L2 is given as A power n, B power n, where n is greater than or equal to 0. What does it mean? This means number of A's and number of B's should be equal. Suppose A, B, this string is accepted by this language L2. Double A, double B, because number of A and number of B's are equal. Now ask the question, can we write regular expression for this language L2? No, we cannot write regular expression. Now some students may think that the regular expression for this language L2 can be A star and B star, but this is not correct. Why? Because the regular expression A star B star means any number of A's followed by any number of B's. Any number of A's followed by any number of B's. It does not say that the number of A's and B's must be equal. So we cannot write regular expression for this language L2. Since there is no regular expression for this language L2, this language L2 is not a regular language. Now another way to check that this language is regular or not is ask one question. Do we need counting? Yes. How? The number of A's must be equal to the number of B's. For example, AB, double A, double B, triple A, triple B. This is accepted by language L2, this is also, and this also. But this string will not be accepted by the language L2. But to verify this, the machine must remember how many A's it has seen. Here it has seen one A, so there must be only one B. Now for this string, machine need to remember that there are two numbers of number of A's are 2. So there must be number of B's should be 2. And a finite automata has no memory, so it cannot keep track of the count. So this language is not regular and no regular expression exists for it. So whenever you get a language in the exam, ask two questions. Does this language need counting? Second question, does it need memory? If the answer is no, then it is a regular language. And if the answer is yes, then it is not a regular language. This simple trick helps you identify regular and non-regular languages quickly. That's all for this video. Thank you for watching.